Hi, this is section 1.2, day 2. We are talking about symmetry in this video. So looking here, we've got 3 different types of symmetry. The first type that they have shown here is when it's symmetrical about the x-axis. In other words, if we took this graph and we folded it along the x-axis, this part of the graph is a mirror image of this part of the graph. So it's a mirror image across the x-axis. So we say it's symmetric with respect to the x-axis. Notice also for this one, for every point that's xy, it's the y value that's changing because it's going from a positive y to a negative y. So when we try to test something algebraically, we're going to put in negative y to see if it comes up with the same equation. All right, and then for the next example, this one here, notice this one is symmetrical around the y-axis. So if you took this side and you flipped it over onto this side, they would line up. It's a mirror image across the y-axis. This time it's the x value, so if you have an x value and you put in a negative x, you should come up with a carbon copy of the equation. And our final type of symmetry is symmetric with respect to the origin. So this image here, if I first reflect it across the across the y-axis, and then take that image and reflect it across the x-axis, these guys would be mirror images. Or if I took it and I folded it along this line here, they should be mirror images. I think I just said that wrong. Maybe it's this line here. Nope. I don't think you can do the folding. So this is a two-fold thing. So one is you take, it's hard to do without showing you with my hands. I take this piece and I reflect it over here. It would look like this, right? For symmetric about the y. Here, that looks a little better. And then if I take this piece and now reflect it across the x, we end up with a piece down here. So not only does the x become negative x, your y values would be negative y. So if we plug in negative x and negative y, we should get the same equation. So let's see what that looks like in context of a problem. So looking at 5a, first we want to look at the graph to decide whether we think it's symmetrical about the x-axis or about the y-axis. And if we look at it, it looks like we can split this guy right down here. We know that's, for a parabola, we know that's our axis of symmetry. So this one is symmetrical about the y-axis. So symmetric with respect to y. You might also hear me say symmetric about the y-axis. And then if we want to test that, whatever point I have over here, the x value should be negative over here. So if we look at this point is 2, 2. If I change this and make that a negative 2, I should end up over here, which we do. So if I'm going to test this algebraically, here's my function. F of x is equal to negative x squared plus 6. If I want to test to make sure it is symmetric with respect to the y-axis, I'm going to plug in negative x, and I should come up with the same answer. So f of negative x would be minus, and instead of x squared, I've got negative x squared plus 6. What happens to negative x squared? That's negative x times negative x, that becomes positive x squared. So this negative still stays up front, but it's negative times positive x squared, which is still negative x squared plus 6, which was my f of x. So that is indeed symmetric with respect to the y-axis. All right, looking at our next example, this one looks like what? We're symmetric against the x, against the y, or against the origin. If I took this piece here, and I folded it across the y, I would end up with this piece. And if I take this piece here and fold it across the x now, I would end up down here. So after those two transformations, if I change both the x and then the y, I get the same piece down here. So this would be symmetric about the origin. For symmetric with respect to the origin. I've heard it said both ways. So to test this one, we have to change x to negative x and y to negative y. So if we plug in negative x for x and negative y for y, we should get the same equation. So negative x times negative x, that would become x squared. Negative y times negative y, that would be y squared, is equal to 25. That is the same equation as up here. So if I put in negative x, negative y, get the same equation, that means we got it right. It is symmetric with respect to the origin. All right, I think that's all we have for the test of symmetry, but before I move on, let's talk about what if it was symmetrical about the x-axis. So let me draw one up here. So say I have this graph. Pretend that like it's symmetrical about the x-axis. So this point here and this point here, this is the point xy, and we're symmetrical about the x-axis. Then this point down here has to be x negative y. So if I'm given an expression for this, say y squared plus 2 is equal to x, and I want to test whether this is truly symmetrical about the y-axis or about the x-axis, I'm going to plug in negative y for y, and I should get the right answer. So negative y squared plus 2 is equal to x. Negative y squared will be y squared plus 2 equals x. So that does give me the same answer. So we are symmetrical about the x-axis for this one. So those are your three tests. Symmetrical about the x, symmetrical about the y, or symmetrical about the origin.